Hi, so for today we're going to talk about the application of definite integrals, more specifically plane areas by integration. So we can use also definite integrals for finding the areas of a plane, of a two curve, okay, in an xy coordinate. So we have two methods of finding the area of the bounded by the two curves, or one curve for the x-axis and one curve for the y-axis bounded by these two coordinates, or x and y. So for areas, we have two formulas. So here we can see that the area is equal to the integral of the so-called y upper minus y lower dx evaluated from A to B if we're going to use vertical strip for finding the area. Okay, for horizontal strip, we have this following formula. We have this formula. We have A is equals to the integral of x right minus x left dy evaluated from A to B. So what does this y upper and y lower mean? So we have to express the curve purely in terms of y. So we have to isolate y, okay, in the equation and express it, of course, all in x so that we can integrate with respect to the x. So what is this y upper and y lower? Well, actually, that y upper and y lower will depend, okay, whether which one of the curve is at the upper side and which one of the curve is on the lower side when we draw a vertical strip. So vertical strip looks like this. So it's actually a very tiny vertical strip. Okay. So yeah, and it has a width, okay, of dx. For vertical strip, here is what we will use. For horizontal strip, I mean horizontal strip. So this will now be our dy. Okay? So as you can see here, we have two methods. Sir, what are we going to use? Well, it depends on the curve. Okay? And it depends also on the given limits or function. Sometimes the limits are not given from A to B, but if the limits are not given, you have to find the limits. Okay? The same as x right and x left. So what are we going to do is to isolate x in the equation, and on the other side of the equation are purely in terms of y, so that we can integrate with respect to dy. So here are our formulas. Okay, for us to really understand it better, we must try to solve some problems involving this application of definite integral, so we can apply these formulas. And again, the rules for finding the areas of the plane along x and y using integrals: first, you must sketch the given curve. Okay, so you must recall the equations of parabola, equations of line, whatsoever given curve, so that we can actually get the area of these curves. Okay, so let's try. So let's try to have example number one. So find the area bounded by the curve y is equals to x squared and the x-axis, and the ordinates x is equals to 1 and x is equals to 3. So first, we have to identify this y is equals to x squared. Now, this is a parabola, okay, opening upward. Okay? So parabola opening upward. Okay, its vertex is at the origin. So what are you going to do? You're going to first make a sketch. Okay, make a sketch of that parabola centered at, or vertex at 0, 0. So here is our parabola. Okay, and then, okay, it says find the area bounded by the curve of the parabola and the x-axis. Here is the x-axis. Okay, so, and the ordinates x is equals to 1. So we have, let's say this is x is equals to 1. And let's say that this is x is equals to 3. Okay. My drawing, or my label in numbers are not drawn to scale. So it means, class, it means that we have to get the area bounded by this parabola, this is our parabola, and the ordinates x1 and 3. So in this case, this is the area bounded. Okay? Here is the area bounded. So let me just draw it once again. So for example, this is our parabola. Okay, opening upward. So bounded by x is equals to 1 and x is equals to 3. So this is our 1 and 3. So what do we do is actually get the area bounded by these two curves. So this would be our point of interest. Okay, this area. Okay, so the question is, what method should we use? Is it a vertical strip or a horizontal strip? So in this problem, we can use a what? A vertical strip. So this would now be our vertical strip. That vertical strip has a length or has a width of dx. So this will now be our y is equals to x squared. Okay? So the formula again, when we use the vertical strip, is area is equal to the from A to B. So again, what's the formula? Y upper minus y lower. So we have y upper minus y lower dx. Okay. Okay. So we have now this. So as you can see, if our method is vertical strip, that means dx, so our limits must be on the x. So as you can see here, the limit to get the area bounded by this, okay, parabola and from the ordinates 1 to 3, meaning that should be our limit from 1 to 3. And what is this y upper and y lower? As you can see here, if you draw this vertical strip, it touches the curve, the parabola. So that should be our y upper, the parabola. And on the lower part of the strip, it touches the x-axis. That is not a function, nor that is a curve. So it is simply the axis. So our y lower must be equal to 0. So our y upper, again, we will express this in terms of isolated y. So we already have this. So y upper will now become x squared. Okay, that is our y upper expressed in x. Okay, we isolated y, that's already isolated. Minus the y lower, since it touches the axis, x-axis, it is 0. So dx. So simply we have reduced this formula into x squared, integral of x squared dx evaluated from 1 to 3. So we know that the integral of this should be x cubed over 3 evaluated from 1 to 3. So that should be 3 cubed over 3 minus, okay, 1/3. So 3 cubed over 3, that is 27 over 3, that is 9 minus 1/3. Okay, this should be 27 minus 1, 26 over 3 square units. This is the area. Okay, this is now the area, our answer for the area. Okay, so first we have to graph the parabola and then identify the limits. In this case, the limits are given from x1 is equals to x3. And then we use the proper strip for that. In this case, we have used the vertical strip. Okay, because we have now the limits from x is equals to 1 to x is equals to 3. So we have the answer 26 over 3 square units. If your answer is actually negative value, that is wrong, because there is no such thing as a negative area. Okay, so for number 4, number 2, find the area lying above the x-axis and under the parabola 4x, y is equals to 4x minus x squared. So First, we have to identify what is the opening of this parabola and at the same time the vertex of this parabola. Okay, so what are we going to do? So first, we can rewrite this as negative x squared plus 4x. Okay, we can factor out negative. So x squared minus 4x. Okay, and that is equal to y. So y would now be equal to the negative if we perform completing the square here. What will happen? So divide this by 2, it would become negative 2, and then you square the negative 2, that would be plus 4. Okay? So, and if we add 4 here, we must also add 4 here on the other side of the equation. But take note, we have a negative here. So technically, when we add 4 here, we are actually subtracting it by minus 4. So here, we will subtract it with minus 4, even though we add plus 4 here because we have a negative here. Okay, and then y minus 4 is equal to the negative, okay, factored form, x minus 2 squared. Now, we have now a parabola, okay, opening downward. So, we have the vertex of the parabola as 2 and 4, okay. This is a parabola opening downward. So the shortcut on how are you going to for me, my method to determine what is the opening of this parabola is that first take a look at the equation, okay, that is side of the equation that is not squared. In this case, that is y minus 4. So y minus 4, y, if you see y here, so there is two openings with respect to y, upward and downward. So how will you know if that is downward or upward? You take a look at the sign again of x here, which is squared. So we have a negative here, so it means it's opening downward. So let me just try to draw. I hope I could draw it. So we have the vertex 1, 2. Okay. So for y, we have, let's say, 1, 2, 3, 4. So that our vertex is here of the parabola, and it is actually opening downward. So if I draw a parabola opening downward, it would look like this. Okay. So this is our x-axis, and this is our y is equals to 4x minus x squared. Okay. So what the problem is trying to say, find the area lying above the x-axis. So this is the x-axis, above the x-axis, and under the parabola, okay, this. So the point of interest, the area we are trying to find is this, bounded by the x-axis, above the x-axis, and below the parabola. Okay, so we have already drawn, okay, the curve. So what strip are we going to use? Well, of course, we can use what? Still a vertical strip here. Okay, we can use still a vertical strip here. For example, we use a strip here so that this would become our vertical strip, and actually its thickness or width is dx. Okay, so if we use a vertical strip, we have a is equals to from a to b, y upper minus y lower dx. Okay, that would be our equation. But the problem here is that we don't know the limits a to b. Okay, we don't know this. Okay, we cannot assume that this is the origin. Okay, we can also have this. So intersection here. So our limits should be in terms of x because we have used vertical strip. So from here to here, that should be our limits. But the problem is that we don't know. So how do we find the limits? Simply from the parabola for x minus x squared. Oops. We know that the parabola actually crosses the x-axis, but we don't know exactly what is the point, okay, of intersection. So what are we going to do is to equate this y equal to 0 and find the x so that we can find the limits here to here. So how do we find that? So 0 is equal now to, we're going to factor out x So we have 4 minus x. So as you can see here, x is equal to 0, 1x is equal to 0, and 1x is equals to 4. Okay, so the limits, the points of intersection of this parabola with respect to the x-axis should be, according to our drawing, that's correct, 0 at the origin and at 4. So our limits will now become from 0 to 4. Okay, again, what is our y upper? So we have drawn a vertical strip here. It touches the parabola. So that must be our y upper. And it should be expressed in terms of x because we cannot integrate it if it is expressed in terms of y. So it's already given. Y is also already isolated here. So we have 4x minus x squared minus y lower. So the strip touches the x-axis. So that is not a curve. So it means minus 0. So we have a simplification of our formula here. Simply, this would be our formula. Okay, so the area would now be, again, okay, if we integrate this, first 4x squared over 2, that should be 2x squared, okay, minus 1/3 x cubed with the limits from 0 to 4. So it turns out that our area would be 2 times 4 squared 16 minus 1/3 4 cube. Okay, so this should be 32 minus 4 cube is 1664 over 3. Okay, so if we perform that, 3 times 32, that is 32 times 3, 6, 96. 96 minus 64 over 3. And 96 minus 64 is 32 over 3 square units. So that is the area bounded by the curve, the parabola, and the x-axis. Okay, 32 over 3 square units. Okay, so moving on. You can pause this video if you actually want to review. Okay, so but let's try to move on. For number 3, find the area bounded by the parabola x is equals to 8 plus 2y minus y squared and the y-axis, and the lines y is equals to -1 and y is equals to 3. Again, the very first step is we have curves 8 plus 2y minus y squared. This is a parabola. So we can rearrange this equation such that we're going to find the vertex, okay, and vertex and the opening of this parabola. So we have x minus 8 minus y squared plus 2y. So x minus 8 will now be equal to, factor out negative, y squared, okay, minus 2y. Then we're going to perform completing the square here. So y squared minus 2y divided this by 2, that is -1. -1 squared would be plus 1. Okay. Okay. Of course, if you added 1 here, it has a negative sign here. So you must subtract -1 here, such that this would be the left side of our equation. So that should be negative y minus 1 squared. Okay. So we have the following. So it is actually a parabola opening to the left. So opening is left to the left, and its vertex is actually on 9 and 1. Okay? 9 and 1. So if we draw the parabola, so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would be the 1. Okay? So our parabola opens to the left. So this would be our parabola. Okay? Forgive me for my drawing. No. Okay, it's not really good, but I'll try my best again. Okay. So let's try to draw. This should be the parabola. Okay. So that must be our parabola. This is our y is equals to, or my mistake, that is x is equals to 8 plus 2y minus y squared. And of course, we have the other given and the y-axis. So find the area bounded by this parabola and the y-axis. This is our y-axis. And the lines, y is equals to -1. So let's say this is the line that is equal to -1. Okay? So this is the line. Let's say line y is equals to -1. And the line y is equals to 3. Let's say this is the line that is equal to 3. So this is the y is equals to 3. So we have two lines here. So the problem is asking find the area bounded by this parabola, y-axis, and the lines y is equals to 3 and y -1. So our point of interest, the area is actually what? This area, well, including the y is equals to -1. So that must be the area. Okay. So the next step is okay, what method are we going to use? Okay, what method are we going to use? What strip? So as you can see here, we can use, since we have the limits from -1 to 3, so we can use the what? Horizontal strip, that is x right minus x left, okay? dy from A to B. In this case, we will be needing a limits that is in terms of y, that is given from -1 to 3. So we're going to use the horizontal strip. So this will be our horizontal strip. Okay, horizontal strip. So this has a width of dy. Okay, and again, the horizontal strip touches the other side. Okay, on the other side, the parabola. And on the left side, it touches the y-axis. So what will happen? Our x right would be actually what? Our x right would be automatically the parabola, this parabola, because it touches the parabola at the right side of the strip. So we have 8 plus 2y minus y squared minus x left. What would be our x left? So the left side of the strip touches the y-axis. So that should be, that is not a curve, that is an axis, so that should be 0. The y limits from -1 to 3. It's given by the lines, right? So if we integrate this, we'll be having what with respect to y? So we have 8y plus y squared, if I'm not mistaken. So 2y squared over 2. The 2's will cancel, minus 1/3 y cubed. Okay? So evaluated from limits -1 to 3. Okay? If we evaluate that, we should be, okay, as I have shown you a while ago, we will evaluate this definite integral. So our answer should be 92 over 3 square units. Okay. So that should be our answer. Now, the important thing here is you know how to graph the curve, the given curve. Then we're going to identify what strip are we going to use, and of course, we have to identify the limits. And after identifying the limits, you have to perform now the integration. Okay, so that is equivalent to 92 over 3 square units. And actually, we have done an example wherein we have only one curve, okay? So lines, a parabola and line. So what if we have a parabola and a line? Also, we're going to find the area of these two. And what if we have two parabolas? So it's also possible. Okay, on the next example, we'll have to try that. Okay. Alright, so let's continue. For number 4, we have find the area bounded by the curve y is equals to x squared minus 7x plus 6. And the x-axis and the x-axis And the ordinates x is equals to 2 and x is equals to 6. So again, they're the same problem. Okay, so we have to identify the vertices of this parabola. So we can transpose 6 on the other side. So we have x squared minus 7x. Okay, so again, we have to complete this square. X squared minus 7x divided by 2 is 7 over 2. Okay, and we square that, so that must be plus 49 over 4. Okay, so if we add here, we have y minus 6 plus 49 over 4. Okay, and then we'll be having x minus 7 halves. Okay, we can try to estimate the vertices of this. So minus 24 plus 49 over 4. Okay, and we have x minus 7 halves squared. So we have 49 minus 23. If I'm not mistaken, that is 23. 49 minus 24. So we have not 25. Okay, so we have 25. So that should be y minus or plus, okay, 25 over 4 is equals to x minus 7 halves squared. Okay, so this is a parabola opening, well, of course, upward with a vertex at the, let's say, we have a vertex at 7 halves and negative 25 over 4. So we can estimate that the parabola we are trying to solve is actually opening. This is as an opening again, upward. Okay, so it has a vertex of 7 halves. So 7 halves is 3.5. So we have 1, 2, 3. Okay, and negative 25 over 4. This should be approximately equal to 4, 8, 12, 16, 20, 24. So negative 6.25 if I'm not mistaken. 2, negative 3, 4, 5, and negative 6. Okay, let's say here, this is a rough graph of our parabola. So opening upwards. So as you can see, it passes this point, but we don't know exactly what that point is. And carefully notice then that my drawing is not drawn to scale. So the point of interest is that the x-axis and the ordinates, okay, is equals to 2 and 6. So if we're going to draw this, okay, so let's say uh, this should be our x is equals to 2. Okay, let's say this is, let's draw again. Okay, let's draw again. Let's try to draw again. Okay, we have an ordinates equal to 2 and 6. So for example, if I'm going to draw this, okay, for example, here is our vertex of the parabola. For example, let's say this is x is equals to 2. Okay, x is equals to 2. And this is x is equals to 6. Okay? So the ordinates x is equals to 2 and x is equals to 6. So the point of interest of our area should be this. Okay? And in this case, what are we going to use? So we are given a limits from x is equals to 2 and x to 6. So from 2 to 6. So we have to definitely use dx here. And what is that dx? If we use dx, we are going to use vertical strip. So y upper minus y lower. Okay? So here, if we use a vertical strip touching the upper part of the strip, so we have a strip here. So our strip would be, what does our strip touches? Okay, so we have a width of dx here. So its upper touches the x-axis, so our y upper should be what? should be 0. Our y lower touches the um, parabola, so that should be negative of the x squared minus 7x plus 6 dx. And of course, if you evaluate that, so we have from 2 to 6, we have the integral of the negative of x squared minus 7x plus 6. Okay? So, dx. So, simply, if we integrate this, we have the negative of the 1/3 of the x cubed minus 7 halves of the x squared plus 6x evaluated from 2 to 6. If you evaluate this, as you're going to evaluate this, so your answer should be equal now to 56 over 3 square units. Take note that it's okay to have a negative here because actually that is the equation y upper minus y lower, and we have a negative here because uh, the y lower is now the parabola. Okay, so if you evaluate this definite integral with the negative, it should give you 56 over 3 square units. Okay, so let's try another example. So here we have already a drawing. Okay, find the area bounded by the parabola y squared is equals to 4x and the line y is equals to 2x minus 4. As you can see here, we have already graphed the parabola and the line. This is the line 2x minus 4 and this is the parabola with a vertex of 0, 0 opening to the right. So, as you can see, we need to use the horizontal strip. You can either use vertical or horizontal here, but it's much easier to use the horizontal strip here. Okay? So, what are we going to do? First, we have already graphed the line and the parabola. So, we used horizontal strip. So, what are we going to do here is what? So, we have area is equals now to the integral from a to b. Since we use horizontal, that is x right minus x left, okay, dy, okay. So, we have to express this equation, these two equation, y squared is equals to 4x and y is equals to 2x minus 4, both in terms of x. We're going to isolate x here for the first equation and the second equation, isolate x. So, if we do that, so we have now x is equals to 1/4 y squared, and here we have x is equals to y plus 4 over 2, that should be 1/2 y plus 2. Okay, and we have now the formula. The problem is we don't know the limits. So as you can see here, the strip is drawn here. So we have what? The x right touching the rightmost of our strip is the line. So that should be our x right line. So it's our equation. This is our equation for the line. So we have 1/2 y plus 2 minus, of course, the x left touches the parabola, which is 1/4 y squared, okay, dy. And the problem is, what are the units? Okay, in order for us to get the units, first, we have to, what? We have to equate these two. Okay? We have to equate these two, or we can equate also these two. So, but we'll try to equate y squared is equals to 4x and y is equals to 2x minus 4. Okay, equate that. So, by simply 2x minus 4 squared, so equals to 4x. So, if we're going to solve that, so we have 4x squared minus 16x plus 16 is equals to 4x. Transposing 4x on the other side, we have minus 4x here plus 16 is equals to 0. So we have 4x squared minus 20x plus 16 is equals to 0. And we can divide this whole equation by 1 over 4. So that we have x squared minus 5x plus 4 is equals to 0. So we can factor out this. So we have x minus 1 and x minus 4 is equals to 0. So in other words, the x-intersection is x is equals to 1 and x is equals to 4. So these are not these are the points of intersection in the x coordinate of this one. So this would be 4, okay? That is for sure. The coordinate x coordinate of that is 4, and the coordinate of this second point of intersection is, well, actually is 1. We don't know the y. So we are concerned to get the y because our limits here from a to b should be in terms of y. And what are we going to do? How are we going to do that? So simply choose one of equation. Let's say I choose y is equals to 2x minus 4. And we're going to insert the roots that we get. So first is 1, 2 times 1 minus 4. So 2 minus 4 is negative 2. So there is a point of intersection that it is negative 2, and it is evident that this is 1 and negative 2. Ito, my drawing is not drawn to scale. Okay? So, and of course, if we're going to insert y is equals to, let's say 4, 4 times 2 here, 4 times 2, because 2x minus 4 minus 4, you have 8 minus 4, that should be equal to 4. So, I can say that this is also 4. So, our concern now is the y-coordinate of the point of intersection. So, we have from negative 2 to 4. So, from negative 2 to 4. So, that will be our limits. Okay? So, let's try to solve that. Again, let me just erase this. Okay. So, again, we have to find the integral of a now is equals to the integral of the negative 2 to 4, 1 half y plus 2 minus 1/4 y squared dy. Upon integrating, we have, okay, y squared over 2. So this would become y squared over 2, that is 1/4. Okay, 1/4 of y squared plus 2y minus 1 over 12 of the y cube evaluated from negative 2 to 4. If we wish to calculate the integral or the definite integral of that, that should be equal to 9 square units. Okay? So that's how you get the area bounded by this two curve or the line and the parabola. Okay? So I hope you enjoy listening to my videos, and thank you so much for listening, and God bless you.